Hi, so these next examples of hypothesis testing are special cases. So we're going to go ahead and take a look at an example where we um, have raw data and then another one where that doesn't meet the criteria. So let's go ahead and take a look. So the first thing we want to do is testing regarding a parameter with small samples. So remember, when the sample size is small and we're given raw data, we can verify that the population is approximately normal by identifying that there are no outliers. So we all love the pennies, right? And so according to the United States Mint quarters weigh 5.67 grams. A researcher is interested in determining whether the state quarters have a weight that is different from 5.767 grams. The researcher randomly selects 18 state quarters, weighs them, and obtains the following data. And we're going to test at 0.05 significance level, and we're going to test whether or not the weight is different than 5.67 grams. So right away, do they give us a mean or standard deviation, right? So no, they give us raw data, and then they say that they want to test whether the weight is different. So this isn't a proportion. We're not taking a proportion of quarters, right? So we would assume the red flag here, this is going to be testing about a mean. So a t-test. And so the first thing we want to do is go ahead and conduct those preliminary tests. Okay, so the preliminary will be about a mean. So n, the sample size n of 18 has to be no more than 5% of all U.S. quarters. Quarters, not pennies. And then, yeah, that's not, there is like tons of quarters out there, right? So yes, right, definitely meets that. The second part is about a mean. That means the sample size has to be greater than or equal to 30. And so that is not the case, right? N equal 18 is not greater than or equal to 30, but less than 30. So now we're somewhere. We are in a place where the second criteria is not met. We do not know that the population is approximately normal, but we do have raw data, and so we can put it in our calculator and display a box plot and make sure there's just no outliers. So let's go ahead and do that. So I'm going to go ahead and go to our calculator and try to get that raw data in there. Okay, and so let's go ahead and go to Stat, and we'll go to Edit, and we'll put our data in a list. So I'll go ahead and put it in list 1. Okay, I went ahead and entered all mine in, and go ahead and hit second y equals, which brings you to stat plot. I encourage you to go to y equals and make sure there's no equations in there, and then hit second y equals and go to stat plot. It just kind of eliminates any potential error. Go ahead and turn it on, and make sure all the other plots are turned off. Notice they're unhighlighted. Okay, and then let's go to the box plot with outliers. And then I'll go ahead and go to my list 1, enter list 1 in, frequency 1, and then I'll make it blue. Now don't hit graph right away. Remember, we go to zoom 9, which is zoom stat. And notice the graph itself, let me go ahead and drag it over, is a box plot, and it has no outliers. The next type of graph, if we go back to the calculator, that we can do to show that, to verify our box plot has no outliers, is going back to stat plot and go to our same plot. And now go ahead and select this very last right end graph. And what that is we call it a normal probability plot. And what it's going to do, it's going to graph like the x-axis, and it's going to show us a bunch of dots. It's going to look like a scatter plot. But what we're looking for is a pattern. And if there's a pattern, then we're okay. If it looks like my 2-year-old went in and started drawing a bunch of dots on the wall, then we would have a problem. So let's go ahead and graph using the same list, everything. I'm just changing the type of graph. So let me hit enter, and let me go all the way down. I'm leaving everything as is. Don't touch, I just changed it to that graph. And then now I go ahead and hit zoom stat. And it gives me this nice little scatter plot. So this one is just that last graph on our grid. So what I want to do is make a note here. I want to make that the box plot has no outliers. And our normal probability plot from our calculator shows a pattern. So because we have no outliers in the box plot and we have a pattern, a distinct pattern in our normal probability plot, we can go ahead and say that the second criteria is satisfied and that our data come from an approximately normal distribution. So here we say, okay, if these two are satisfied, then our data comes from an approximate normal distribution. Okay, so when you're given that, just go ahead and look for those two. The box plot usually is enough, but you know, I get it, like I'm a nervous Nelly, so I have to do the other one as well. But those are the two common ones that you'll see, especially in your research methods class. So after all of that, we haven't even started the problem. So let's go ahead and do the problem. So that's the special case, right? The special case is when you do not meet one of the criteria, and about a mean, you could go ahead and do that box plot and probability plot and then make sure the criteria is satisfied. Okay, so let's go ahead with the problem. Now let's go ahead and start the hypothesis test. All right, and we know we're going to do it about a mean. So 1i would be h sub 0, h sub 1. Let's go ahead and look at those. So we're looking for the average quarter's weight to stay at 5.67 right, grams, right? Status quo. The alternative would be what the researcher is looking into, right? So the researcher thinks that the weight is different. So the fact that the weight is different would mean that it would be two-tailed, right? It doesn't say if it's less than or greater than, it's just two-tailed, and then mark it that it's the claim. So when we go ahead and go into number 2, right, we know that it's two-tailed, and then the alpha that they want us to use, which is given, is 0.05. So this means that this alpha is split into 2, right? And we have 2 critical regions. So alpha over 2 is literally just 5% divided into 2, which we can already see that it's going to be 2.5%. And then here, the population parameter is at 5.67 grams. So we just need to see where the p-value lies here. Okay, and so now we have it. So let's go to step 4, which is the p-value approach, right? And then we'll go ahead and go into the calculator. Now recall we're doing a mean, so we have to do a t-test. And we go to our calculator, hit stat, go to test, and t-test is number 2. And here, notice they give us stats and data. So we don't really have any statistics. We put all our data in which list, right? List 1. And we are testing whether the population mean is different than 5.67 grams on a quarter. And change your list to where you put it. I put mine in list 1, but it's up to you where you put your data. It is two-tailed, and I'm going to color and then I just want to note that you can draw it. Don't be afraid to try stuff in your calculator. That draw, if I click it, it'll give you the normal curve and actually shade the two tails. The only problem is that it only gives p-value to 4 decimals, so if you can't really see anything past the 4. So if it was like 0.000006, it would show it as 0. So if you want the exact number, go ahead and use the other one, calculate. So this one gives the test statistic and the p-value, and you can see that it shades it on both regions. Let me go ahead and drag that in there so you could see. And because this p-value is a little bit larger than the other ones, we can see it here. But if I went back to stat and test and did a t-test and just did the calculate, it would give us that other menu as well with the test statistic p-value, and then it gives us the mean and standard deviation of the raw data that wasn't given to us before. So it's just really up to you. I prefer this menu with all the data versus the grid because it's nice if you don't always want to draw it, right? If you don't want to do this figure, then you have this in your calculator to do it for you. But if the p-value is too small and you need to enter it in homework or write it out, you're going to need this menu below. Either way, it works out. Okay, so now let's go ahead and take the p-value. The p-value is equal to 0.0136, and alpha was 0.05. And so remember that the p-value they give you is actually the total probability between both. So this is just the probability. So in this case, we could split it in half and then see where that lies, but it's going to end up being the same. So just always take the p-value. With the two-tail test, take the p-value and just always compare it to the alpha no matter what. And if we compare the decimals, we can see that the p-value is smaller than the 0.05, and that means that if I took another random sample, it's going to be that chance is going to keeping status quo is smaller than a type 1 error, and therefore there's going to be some sort of change, and this is statistically significant, and so we're going to go ahead and reject the null, right? And this is statistically significant, stat sig, right? That sounds so much cooler. So if we reject our null, come up here to step 1, cross it out. What are you left with? Circle it. Then look to see where your claim is. Say, oh, did the researcher have enough evidence to support his or her claim? And yeah, right? So the last step we always do is interpret in terms of the claim. So we would say that there is enough evidence to support the researcher's claim that the quarter's weight is different, 6-7 grams. Okay,